This is the fourth LeetCode challenge that I'm doing in Go, and it is called Median of Two Sorted Arrays. Given two sorted arrays, nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be O log m plus n. So if you have nums1 array, which is 1 and 3, then nums array, which is 2, it will output 2. So with these two arrays, they are merged together in order, and the median is 2. Then with these ones you have 1, 2, 3, 4, which has an output of 2.5. And that's because when you merge them together, there is no longer a median, as there is an even number of items. So what you then do is grab the two middle numbers, combine them, and then divide it by 2 to get the median, to get the number between both of them, which would be 2.5. Okay, so let's get started. So as this involves two already sorted arrays, we will need to do binary searching through them to more efficiently find the median of it. So first thing we need to do is figure out which of these arrays are the smallest in size. So what we're going to do is start off with we'll do small nums, and this will be int. Then we can do large nums int. So we'll start off with this, and we can do if length of nums1 is greater than length of nums2, small nums equals nums2, and large nums that. And if that's not the case, just do else, and we will swap them around. Okay, so we've now got the small nums array and the large nums array. Well, we first need to know the actual length of it, so we'll do small length equals length of small nums, and then we'll do large length. So with the binary search, we'll be primarily searching over the length of the small one. So we now need to create our low, which starts off as 0, and our high, which starts off as the small length. And now we just need to do keep running while low is less than or equal to high. So what we'll be doing now is kind of logically breaking up both the arrays into two separate segments. So with small nums, we'll be creating a small segment and a large segment, or I should say, splitting it down the middle. So we have one array which has all the lower numbers and one with all the higher numbers. Same thing with large numbers, break it in half, lower numbers and higher numbers. So that's what we'll do initially. So for the small one, we'll start off with small partition, and this number, or all the numbers we're already doing, are based on the small, the length of the small one already. So we can just do low plus high divided by 2, and then this will give us cut down the middle of. This will get us the middle index of the small. But now for the large partition, this will be for slicing down the middle of the larger array for when we're splitting them up. So the way you create this number is a bit different. So first start off with the length of the start with small length, and then you add large length to it, and then you add 1 to it. This add plus 1 will make sure that the median of the larger array is always in the left smallest section of it. So we do that, then divide by 2, so we get the halfway point, and then we minus by the small partition. So when the small partition changes based on the low and the high, the large partition follows in suit with it. So we've now got these two numbers, and now it's a matter of using these partitions, which are actually like indexes we'll be using. We're now using these partitions to logically separate both the small nums array and the large nums array into their own two sections. So I guess the way to think of it, what we're doing is, with this partition we're going to create, so small partition with the small nums array, we're going to create a left section and then a right section. This left section will have the smallest numbers in the small nums array, and the right will have the largest. So what we first want is to find out what the largest number in this left max segment of the smaller one is. So we'll create an initializing variable to begin with. So left, we'll call this left small max. So the left partition of the small array and the maximum number on that. So I'll first need to import math, because that we don't actually know what numbers are going to be in it. So better for us to use the built-in math to just create like the maximum possible number. So back down to here, this will be math dot max in 64. So I've got this to begin with, and we will do if smaller partition is greater than 0, the left small max is equal to small nums, and we're getting the smaller partition of it. So we've got this. Now it's on to the next one, but this time we're doing the right side of the smaller. So just right and right. Oh, I shouldn't have renamed that. I should have stayed small. But now what we're trying to find is the smallest number of the left side. So we do min, and in the small one, so this index, this small nums array is still technically one whole thing, but just like we've got a fake split between it. So this index represents the maximum of the left index. So now we need to do, oh, actually I just realized this should have been -1. So this one, small partition -1, is the highest index of the small nums array, which is a part of the left partition of it, and then the actual small partition number index is the first index in the right partition. So I've now done all that, and then we are essentially just doing the exact same thing, but for the large one. So left large max, right large small, and this time will be the large partition using left large max. And well, actually I've just realized I forgot to change the condition here. So for the right small partition needs to be less than small length. Okay, that's been wondering why I've been getting squigglies for this, but now I know it's because I forgot to do that. So what's the reason for squigglies here? Okay, that's fine. So small partition needs to be less than small length. That's fine, and then this one needs to be greater than, no, this needs to be smaller than large length. So we've now got all the numbers from it, and now we're needing to check. We now need to check to see if the partitions that we originally created are valid, in that the numbers we've taken from the indexes are actually like the median numbers. So we now need to do a check to see if that's the case. So we'll start with left small max. This needs to be less than or equal to right. I just realized I've still called this should be min. This should be min. So right large min. So left small max needs to be less than right large min. Then we need to go left. Which one is this? Left large max needs to be less than or equal to right small min. So if this is the case, then we've found the middle point. So we've got the two separate arrays. We've found the indexes within each of them where they perfectly match. So I've split them down the middle. We've found where the actual median within those arrays are. So now we've actually found that point. It's a matter of just finding out what the median is. So there's two different, depending on whether it's an even array or odd, that changes. So let's do if, what are the length variables called? Small length plus large length, modulus 2 do equals 1 for the odd. So if we're doing odd, we need to return. So one of these values has the actual number, and it should. Which one would it be? That's right. So because of this, actually, I'm gonna just create a few helper functions. So, oh, not function, func. So we've got. So we need to figure out the max and the min of the numbers we currently have. So max, just do a, b, int, we return int. So if a is less than b, return b, and then return a. Do the exact same thing but min, but switch these around, a, b. So initially with this one, we will be returning the max, and this would be of which one? I think it left small. So the small one, it would be the. So I've got the two partitions, left, right. Got the max and the min. It will be the left small max, and it should be the right large min. And then we need to turn this into a float 64. So that's if it's an odd amount where we know there's a specific value. What we now need to do is handle when it's even. So it'll be a very similar thing. So we start off with this again, but we now need to do the min of right small min, right small, and right. Wait. Okay, no, I messed this up. This should be right. It's the left of both of them. My mistake. That's what the plus one was for, was to make sure that on the larger one, it would be here. That's right. So min, and now it's both the right large min. So we've got these. Okay, I need to change how this is done. So we will be adding these two together. We need to add parentheses around it. Then we need to divide it by 2. Yes, that should work. So if we have the correct partitions created, then we return. But if we don't, we then need to adjust the partition number. So for that, which numbers would we be looking at? So it would have to be either of these are wrong. So if left small max is greater than right large min, so if left small max, that would mean this number should be in the other partition. So we would need to move it. So the highest in here needs to be here. So we'll need to move it to the left. So that would mean reducing the number. So that would mean the higher needs to go down. And so small partition -1. And if it's not this condition, then it means it's this one, where left large max is greater than right small min, which would then mean we need to shift it upwards. So low, and this would be +1. Ah, my bad, I forgot to rename these. Okay, now that's correct. Need to just add a little return 0 there. So let's give this a run and see if it works, which it doesn't. It returned 1. So I should have returned 2.5, but it didn't. I guess let's take a look at it slowly. Try to figure out where we went wrong. So this is correct. What's going on up here? The value of small nums never used. Okay, well let's go to here. So small partition, low, and then highest this length of small. So small partition, low plus high divided by 2. So we're starting in the middle point. Large partition, we're using the length of the small because that fits inside the large array. So grab this number, we're adding these together, adding 1 so we can ensure the length. If it's an odd number, it ensures the number is in the left partition. So grabbing that, adding those together, divided by 2 so we get the middle, and then minusing small partition so it matches. Alright, so this is creating the length of the full thing. So we've got the length of halfway point of the full thing, and then we're offsetting by small partition. That's right. So that appears to be correct. So left partition of the small one and the maximum, or the maximum number, I guess. Start off max index, which is fine. If small partition greater than 0. Actually, I've got these swapped around. When we're finding the max, we need to set it as the minimum possible number. I don't think that's caused. That would be the problem, but who knows? Maybe. Okay, that wasn't it, but it was a mistake. So left small max, small nums array, and with small partition going to the left one. That's fine. Right small min, start at the next number. Small partition needs to be less than the small length, which is fine, I think. Small partition, small nums, right small min, that's all good. Just need to make sure we're assigning all the same correct values. Left large max, that. Large partition. Oh, there we go. This should be large. Now hopefully that was the problem. Interesting, we're getting 2 now. So I feel like this is now where the problem is. So left small max needs to be less than or equal to right large min. That is correct. And the left large max needs to be less than or equal to right small min. And that's also correct. So if these conditions are met, that means we have found the correct sections. So small length plus large length modulus 2 equals 1. We have an odd number. And that means the number is within the arrays. So we're trying to find the max, and it's left small max, left large max. Yes, that is correct. If these conditions are wrong, if it's an even amount. Ooh, actually, the mistake is here. I've got the divided by 2 inside, so it's doing the integer arithmetic, then it's doing divided by 2, so it's keeping it as an integer. So we need to take this out and have it like that. There we go, now we're getting 2.5. So let's grab all this code. We will chuck it into LeetCode. We will run on the test ones. The test cases are correct, which is promising, so we will now submit it, and hopefully it works. Which in this case it did. So that was the 4th LeetCode challenge, median of 2 sorted arrays completed in Go. If you like this video, make sure to like and subscribe.